Welcome back. In this session, we are going to go through the requirement to build one of the aggregate tables in our gold layer. First, we will go through the business requirements and then the non-functional requirements. Once we understand the requirements, we'll take a look at the data that we need to gather in order to satisfy the requirement and the solution. To achieve that, let's start with a business requirement. Let's assume the NYC Taxi and Limousine Commission wants to encourage customers to make credit card payments, and they want to achieve 90% of all payments to be made by credit cards and keep the rest of the payments to be less than 10%. As you can imagine, the company would want to know the current ratio between the cash and the card payments so that they can track progress over time. So we need to provide the data required to measure this, which will be the current number of trips made split by payments using credit card or cash. In order to achieve the desired change in behavior, the company should run campaigns. The campaigns could be such as advertisements to end credit card payments, discounts to taxi fare when the customer is using credit card payments, etc. Having said that, they want to run this campaign effectively, which means target 1, lead the right customers. The company suspects that the payment behavior is different during different days. For example, there are less card payments during the weekdays than the weekends, or vice versa. In this case, running the campaign during the weekend could be more efficient compared to the weekdays. So we need to provide the data required to identify the payment behavior per day and mark a day as weekday all weekend. Finally, the company wants to break down this payment behavior by boroughs so that they can run campaigns in the right boroughs where the card payments are low. Let's now take a look at the non-functional requirements. The assumption is that the data volume for this project will be in hundreds of millions of trips per month. So we want the output to be aggregated and stored in the reporting layer or the gold layer so that the data could be refreshed quickly in our reports. We want to have the ability to aggregate the data for just a month in isolation. What that means is whenever we receive data for a new month, we want to be able to process just that data and add to the gold layer incrementally. If we choose to process all the historic data, every time the data pipelines will run longer, which can increase the latency of the data as well as increased cost. And we wouldn't want that. Similarly, we want the data in gold layer to be partitioned by year and month so that we can cut a specific month efficiently. Finally, we have a few requirements here, but we wouldn't want to have too many tables, each to satisfy individual requirements and resulting in duplication of data. For example, we wouldn't want to have a table to hold weekend measures and another one to hold measures for each of the weekdays. Instead, we want to have one table with flags to indicate each of these variations. Hope that makes sense. Now let's take a look at how we are going to solve this problem. Let's start by identifying the data items required in our gold table first. Let's start with the business requirements. For the first requirement, we need to calculate the trips for which the payments are made by cash as well as card. Let's call these two data items cash trip count and card trip count for the second requirement. We need to have the trip day that day of the week in which the trip was made. For example, Monday, Tuesday, etc. so that we can run campaigns on the days most in need. We can also have a flag to indicate whether the trip was made during the big day or the weekend. This is so that the consumers of the data can use this flag in reporting rather than deriving this information from their trip day. Finally, we need to identify the payment behaviors specific to boroughs. So we need the boroughs too. Now, let's take a look at the data items required to satisfy the non-functional requirements. Most of the requirements here dictate how the data should be processed and stored in order to make the reporting more efficient. But the requirement here requires us to store the data using partitioned columns on each year and month so that the data could be accessed to efficiently using the year-month by the concept of partition pruning. With this information, we can define our gold table or the file with the columns listed here, which will be a year and month that is required for our non-functional requirement. And the rest of the columns here are from a business requirement. As we've seen, we'll need the trip data from a silver layer to get the trip information taxi zone, to get the borough calendar to identify the day of the week for the trip and payment type to identify whether the payment was made using card or cash. Let's now map these columns required in the gold layer to the silver layer. As we said before, we can get there each month and trip data from the trip data file. We can get the corresponding borough from our taxi zone file. We can get the day of the week for the trip date from the calendar file. The weekend indicator can be derived from the trip day. It'll just be a flag based on whether the trip is a Saturday or Sunday or any other day of the week. The cash trip count and the card trip count will require both the trip data and the payment type. Payment type helps us identify whether the transaction is a card or a cash transaction. We can use it together with the number of trips from our trip data to derive these two data items. So this is the structure of the gold table and the source data used to populate these columns. That's the end of this session. In the next session, we'll take a look at implementing this.